Welcome to a new lesson. In this lesson, we'll be applying the exponent laws. So let's review the exponent laws first. The product law. When we have the same bases and we multiply the powers together, we add the exponents. For example, 3 squared times 3 to the power of 4 is equivalent to 3 to the power of 2 plus 4, which is 6. The quotient of powers. Whenever we have the same bases for powers and we divide, we subtract the exponents. So let's take a look at the example. 3 to the power of 6 divided by 3 to the power of 2 is 3 to the power of 4, because 6 minus 2 is 4. The power of powers. So whenever we have a power of a power, we multiply the exponents together. So in this case, we're going to multiply 2 and 3 together, and we'll get the answer of 3 to the power of 6. We have powers of a product. Now when we have two different bases inside the bracket, we multiply each and every power by the exponent that's outside. So in this case, the exponent inside the bracket is 1, and 1 times 2 is 2, so it's going to be 3 to the power of 2. And 1 times 2 is 2, so we're going to have 4 to the power of 2. Power of quotient. Whenever we have a fraction and the whole fraction has a power, therefore each and every numerator and denominator has that power as well. So in this case, 3 has a power of 1, so is the 4. In order to expand it, we'll multiply the 1 and the 2 together and the 1 and the 2 together to get 3 to the power of 2 and 4 to the power of 2. The last exponent law is the negative exponents. How do we deal with negative exponents? We're going to use reciprocals. For example, if we have 3 to the power of negative 2, it is the same thing as 1 over 3 to the positive exponent of 2. Same way as if we have negative exponent in the denominator of a fraction, so like as this one, 1 over 3 minus 1 over 3 to the power of negative 3, we can switch it to a positive exponent without having a fraction now. So it's going to be 3 to the power of 3 with a positive exponent. We're going to use these laws in the following examples. Simplify by writing as a single power. Explain the reasoning. So the first thing you need to identify is what is the base. The base is 0.3. And the exponents are negative 3 and 5. Since the bases are the same, the bases never change. It's always going to be 0.3. Then identify what operation exists between these bases. The operation is multiplication, so we're going to use the product law. The product law says that we're going to add the exponents together. That means we're going to add negative 3 plus 5 together. And we will get 0.3, and negative 3 plus 5 is 2. So our explanation is that we used the product of powers. Let's take a look at question B. We're going to use the same idea. We're going to recognize the bases. And the bases in this case are negative 3 divided by 2. Then we have to recognize what their exponents are. So we have negative 4, 2, and 2, and 3. Since we have a power of a power, we're going to use power of powers. Don't forget the equal sign. In this case, since we have power of power, we're going to multiply the negative 4 by 2. And same thing as negative 3 over 2. We have power of a power, so we're going to multiply 2 times 3. The bases don't change. Negative 3 halves. Negative 4 times 2 is negative 8. Times negative 3 halves. The bases don't change. 2 times 3, which is 6. And it's good measure to write power of power. Power of power law. Then again, recognize what operation exists, and this is multiplication. Since now we're going to use product of powers. The products of powers tells us that we're going to add the bases together. Sorry, not the bases, but the exponents together. So we'll get negative 3 halves. Negative 8 plus 6 is negative 2. And it's a good practice to write what we're doing and the rules that we are using, products of powers. And now since we have a negative exponent, we're not allowed to have a negative exponent. We're going to switch this using the negative exponents rules to make sure that our answer has a positive exponent. So what happens is that because of negative exponent, our fraction is going to be reciprocated. That means 2 will be now on top and 3 on the bottom, and it's still going to be negative. And now our exponent changes to a positive 2. And that is our answer. And we can use negative exponents rules. Let's take a look at the next problem. So again, we are going to change this to single power, and I'll explain how we're going to use it. So again, recognize what's the base. In this case, it's 1.4. Whether it's a fraction or a whole number or a decimal, it doesn't matter. Then recognize what operations exists. Well, we have multiplication here. So it's a multiplication between the brackets, and there's a division. So 2 things we're going to be using. We're going to use the product and quotient rules. So in other words, we're going to add the exponents, 1.4 to the power of 3. We're going to add the 4 and subtract the negative 2. Now this is crucial. Notice that we are subtracting, but since we have a negative exponent, we still have to have that in our subtraction. Therefore we get 1.4 to the power of 3 plus 4 is 7. 7 minus a negative 2 is actually a positive 9. And here is our answer. Now let's solve question D. The first thing is that we have to identify the specific basis. In this case, the base is 7. Then since we're dealing with brackets, we should identify what type of rules we are going to be looking at. And the way we do that is by looking at the multiplications, divisions, additions, subtractions, operations that we have in this question. Well, we have division, so we have to use the quotient rule. And then we have multiplication, so we have to use the product rule. What I'm going to do is I'm going to use the product rule first, then I'm going to use the quotient rule. Oh, and of course the last thing, because it's outside the bracket, we'll have to use the product of product rule, or power of power rule. Power. So the first thing is that I will use the product rule, so we're going to add the exponents for the bottom denominator. So 7 to the power of 2/3, and we have 7 1/3 plus 5/3. And the reason why plus is because product tells us that we have to add the exponents. So let's add the exponents together. We'll leave the numerator the same, and 1/3 plus 5/3 is 6/3. So 7 6/3 and to the power of 6. Now we're going to use the quotient rule because of this division right here, And division tells us that as long as the powers are the same, so that's 7, the base is the same, we can subtract the exponents. So 2/3 minus 6/3 is negative 4/3. And don't forget the power 6. And now we have powers of powers. So I'm going to continue the question right here. Now, powers of powers means that we have to multiply the 6 by the negative 4/3. It's 6 over 1, remember that. Why is it important? Because when you're multiplying fractions, and I'm going to do it on this side, negative 4/3 times 6 over 1, we have to multiply the numerator of the numerator and the denominator of the denominator. So we'll get negative 24 over 3, which is negative 8. So this is equal to 7 to the power of negative 8. The last thing we have to deal with is this negative exponent. We cannot have negative exponents in your answer. So now this means that we have negative exponents. We have to use the negative exponent rule. The negative exponent rule says that 7 to the power of negative 8 becomes 1 over 7 to the positive exponent of 8. And this is our answer. Let's take a look at a different example. In this example, we're going to simplify, and we're going to explain the reasoning behind it. Again, we're going to use the rules that we've touched upon. But now, it's a little bit going to be different, is that we're going to be using a number of different variables. Let's start with A. So we have x to the power of 3, y to the power of 2, and x to the power of 2 and y to the power of negative 4. So we have to recognize the common bases. So we have common bases of the x and common bases of the y. They're different and separate. Then the next thing we have to recognize that there is a multiplication between the brackets. This means that we have to use the product rule. The product rule says, again, is that if the bases are the same, we can multiply the bases together by adding the exponents. So let's do that. Since x's are the same, we're going to add the exponents for the x's. And also we have a y. Since y's are the same, we're going to add the exponents for the y's. We could even drop brackets at this moment, or we could have the brackets. It doesn't matter. And don't forget the multiplication sign. We usually don't write the multiplication sign between x and y because it's redundant and it's understood to be present. Let's add the exponents. 3 plus 2 is 5, and y is 2 plus minus 4 is negative 2. Now we have a negative exponent, and our answers cannot have negative exponents. It's a convention, it's a rule. So we have to use the negative exponent conversion. So x to the power of 5 is the same thing as 1 times, now notice I'm including multiplication, y to the power of positive exponent 2. Now I'm putting 1 underneath x to the power of 5 because it is a fraction. Every whole number is a fraction which has a 1 underneath it. And we're just going to multiply the numerator with the numerator and the denominator with the denominator. And the answer is x to the power of 5 below y to the power of 2. And this is our answer. You could have skipped this step and immediately proceeded from this line to here. Now, hopefully there's enough room to do part B. Let's take a look at 10a to the power of 5, b to the power of 3 over 2 times a to the power of 2 and b to the power of negative 2. Let's recognize the bases first. So we have A and B. Forgive me, and I'm going to write B in green. We also have 10 and a 2. 10 and 2 are coefficients of these terms. We could simply divide 10 by 2, which is 5. And that's right away reduced for us. In this case, we have a quotient rule to discuss. Why quotient rule? Because we have this division sign. This line represents division sign. Since it is a division, quotient rule tells us that we have to subtract the exponents of the same bases. So since A is the same base, 5 minus 2 are the exponents. And B has 3 minus negative 2. We have to keep the negative for the exponent for B. And it can be just 3 minus 2. Let's simplify this. We have 5 times a to the power of 3, because 5 minus 2 is 3. And B, 3 minus negative 2 is 5. Notice there's no negative exponents, therefore this is our answer. And in this case we used the quotient rule, and we should probably write it down, the quotient rule. Let's take a look at a different example. In this example, we're going to simplify and explain the reasoning. In this case, in A, the only difference is that we're going to be dealing with fractions for our exponents. Since we're dealing with fractions, we need to put each exponent into a fraction form, if it's not a fraction now. This means the 3 becomes 3 over 1, the 6 becomes 6 over 1, and the 8 also has an exponent of 1, which we do not write, and then we have to make it into a fraction, so we have to put a 1 over 1. I'll show you why this is important in about 2 seconds. The reason why it's important is because this is a power of powers. We recognize power of powers rule because of the bracket and the exponent outside the bracket. The rule is that this exponent has to multiply with each and every exponent inside the bracket. This means that 8, 1 to 1, has to be multiplied with 1/3. A to the power of 3 ones has to multiply with 1/3. And B to the power of 6 over 1 has to multiply with 1 over 3. We have to use now our fraction multiplication, where we multiply the numerator with the numerator and the denominator with the denominator for all of our fractions. When we do this, we get 8 to the power of 1/3, A to the power of just 1, because 3 times 1/3 is just 1. And we get B, 6 divided by 3, which in other words is 6 divided by 3 is 2. If it's possible to reduce this, you should reduce it. We should simplify it. On the side, we know that 8 1/3, whenever we have a fraction for an exponent, the denominator is the index of the radical, meaning that this is a cube root of 8. And a cube root of 8 is 2. So to simplify this further, it's going to be 2a times b squared. And this is your answer. Similarly, we're going to use the same type of multiplication of fractions with exponents for part B. And I'm just going to erase this because I don't have enough room. So for part B, we have x to the power of 3/2. I'm just going to recopy it. And I'm going to use specific colors to segregate the x and y. So I'm going to use green and blue for the x, and y, I'm going to use green. Again, the rule is that we are multiplying in this case, so we're dealing with the product of powers. Again, we're going to be adding the exponents. That means x 3/2 will be added to 1/2, and y to the power of 2 will add -1. I'm going to use brackets for -1. This means 3/2 plus 1/2 is 4/2. Remember, when we are adding fractions, the denominator has to be identical while we just added the numerators together. And for the y, since there is no fractions, it's easier for us to just 2 minus 1, which is 1. And let's simplify. It is x to the power of 2 times y. And this is your answer. Let's continue on with some more examples. How about C? Again, it's very important to identify what are the specific powers and bases. So we have A as a base, and we have B as a base. We also have something, a reduction. We could right away divide 4 by 2, and we get 2. Recognize that we have division, so we have to use the quotient rule. That means we're going to be subtracting the powers. So let's subtract powers. We have A, -2, and we're going to subtract the exponent that you see below, which is 2. And we have also B as a base. We have 2/3, subtract 1/3. And if you want to use brackets to separate the exponents, by all means, please do so if it helps you visualize. We still have the 2. We have A, -2 minus 2 is -4. And for B, 2/3 minus 1/3 is 1/3. Since we have a negative exponent, convert the negative exponent into a positive. We could right away jump to the answer by placing the A in the denominator with the power of 4, with a positive. And that is your answer, with a positive exponent. Let's move on to D. Again, recognize with D the specific bases. We have A and we have also a B. We're going to do the operation inside the bracket. We could first reduce it by dividing 100 by 25, and that is 4. And don't forget the bracket. And since we have A's and a division sign, we have to use the quotient rule. So we're going to be subtracting the A to the power of 1 minus to the power of 5. Recall that if there's no exponent, that exponent is always 1. And we're going to leave the B to the power of -1/2. Don't forget the 1/2 outside the bracket. We're going to continue on. So we have 4a to the power of -4 divided by b to the power of 1/2 to the power of 1/2. Let's stick to the bracket. We have a negative exponent. We have a negative exponent for the a and b. We need to reciprocate a's and b's, but leaving the 4 alone. We cannot have negative exponents in our answers. So inside the bracket, the 4 stays alone, but now the b becomes positive 1/2. It moves to the top of the fraction, and a now is moved down below because it it switches to a positive exponent, and now it is reciprocated. We're almost finished. Because of that 1/2 outside the bracket, we're going to use the powers of power, to bring this exponent into, by multiplying each and every exponent inside the bracket by 1/2. Don't forget that the 4 has an exponent of 1. And we have to make it a fraction because the exponent outside the bracket is a fraction. So the 1 becomes 1 over 1, and the 4 becomes 4 over 1. And we are going to multiply. I'm going to finish up top. So we have 4, 1 to the power of 1 times 1 to the power of 2. We have b, 1/2 times 1/2. And a to the power of 4 times 4 over 1 times 1/2. Following the rules of operations with fractions, we multiply the numerator, the denominator with the denominator. Now we lose the bracket because the exponent outside traveled inside the bracket, so there's no more brackets. So our final answer is 4 to the power of 1/2, well, almost our final answer, b to the power of 1/4 over a to the power of 4 over 2. To simplify this further and finally get the answer, 4 to the power of 1/2 is 2 because it's the same thing as square root of 4. And b remains 1/4 to the power of 1/4. And a is, since 4 times 1 is 4, and 1 times 2 is 2, 4 divided by 2 is 2. This becomes our final answer. We're almost done. Now let's use a little bit of application. A sphere has a volume of 425 meters cubed. Now notice it's a volume because of this cube value, 3. What is the radius of the sphere? So we're looking for the radius, question mark, if to the nearest tenth of a meter. So we have a volume, we're looking for radius. What is the formula for the volume of a sphere? Well, the volume of a sphere is 4/3 pi r cubed. So we're looking for radius and we have volume. Let's plug in those values. Volume is 425. We have 4/3 pi r cubed. We're looking for the radius. There are a couple ways to do this question, and we're going to use it a pretty easy way. What we're going to do is we're going to combine the 4, the pi, and the 3 on the right-hand side into one number. In other words, 4 times pi divided by 3 is 4.188 repeating. Sorry, 4.86 repeating times r cubed. Then since there's an operation of multiplication between 4.186 repeating and 6 and r cubed, in order to isolate for r, we're going to divide both sides by 4.186 repeating. When we do this, 4.186 cancel, and r cubed becomes 101.513. In order to solve for r, we're going to take the cube root of both sides of the equation, and r will become 4.7 meters. So that's a pretty straightforward way to calculate this. There's one more way to calculate this, and we're going to use cross multiplication for this purpose. So let's erase everything except for the answer and the initial formula. So let's plug in again 425, and we have 4/3 pi r cubed. So when we cross multiply, we're going to make the left side and right side having a fraction. And 425 by 1 is the same thing as 425. Then we're going to multiply by moving the 3 across the equal sign and moving the 4 pi across the equal sign as well. But since the 4 pi was in the numerator, now it comes to the denominator. So now 425 is on top and the 4 pi is on the bottom, while the 3 moves to be multiplied with 425. And that is equal to r cubed. Now all the numbers are gone. This will give us the same value as before, 101.5. And then again we cube root it, and we'll get the same answer, 4.6. Those two methods are satisfactory to solve